We were continuing. So we were continuing. We were able to see that as you go down, generally the group one elements, they have low density. They have low densities from as compared to the rest of the metals. They have low densities as compared to the rest of the metals. They have low melting and boiling points, but the melting and boiling point further decreases as you go down. They have generally they have low melting and boiling points, the group 1 elements, the alkali metals. But as you go down, their melting and boiling point or decreases further, because the metallic bonding becomes weaker and weaker. The metallic bonding becomes weaker and weaker. Weaker, right? We already know this from bonding, right? Remember, we were able to see this in bonding. What was the bonding? Basically, bonding was metallic bonding was forces of attraction between the sea of electrons and the positively charged ions, right? This is what metallic bonding was. So as you go down the group, for group 1 elements, this metallic bonding becomes weaker and weaker. All right. They have low densities. Generally, as compared to the other metals, they have low densities. But if as you go down the group for the metals, you will see that the density generally increases. And the reason the density increases is because of the increase in the number of shells and the mass, the atomic mass. Do you understand?
Sir,
Yes. Yes, sir. Rizwa, bole.
I said yes, sir. I understood.
Alhamdulillah. So this is what is going on, right? So furthermore, their reactivity actually increases as you go down their reactivity their reactivity
Increases.
down the group, because they're metals. For metals we have already studied. So as you're going down the group, their reactivity is increasing, and the reason for the increase in their reactivity is what? As the nuclear charge decreases, the reactivity increases. Why is that? You see, as the shells are increasing, as the number of shells are increasing, the electrons that are present at the outermost shell, their distance increases from the nucleus. So the nuclear charge on each electron is getting lighter and lighter. The attractive force from the protons present in the nucleus and the electrons outside becomes weaker and weaker. And what happens? The ease of losing electrons become greater and greater. Ease of losing electron becomes greater. And the metallic, this is what metallic property is. uh, if a metal is a good metal when it is able to lose electron very quickly. If it loses electron with a swiftly and easily, that is when it is called a more reactive metal. If you look at sodium and lithium as compared to the rubidium and the caesium, you will observe that they're more, caesium and rubidium are more reactive. Why? They are larger in size, they can lose electron more easily because there is less nuclear charge on the electron. Do you understand? Is this clear?
Yes.
Dear Lijba, are you sure?
Yes, I'm sure.
So we were talking about how to predict. How to predict. You can easily now look at the periodic table and you can tell for the elements whether what would be their trends. If somebody gives you lithium and they give you potassium, They ask you to compare which one of them is going to have a higher melting point, Alishba. Which one of them will have a higher melting point? Lithium and potassium. Yes? Can you tell?
Sir, potassium.
Potassium will have higher melting point? No. We know if you go down the group, the melting point decreases. Look at lithium and look at potassium. Lithium is higher in group 1 and potassium is lower in the group 1. So this is going to have low melting point as compared to lithium. Lithium is going to have a higher melting point as compared to potassium. Do you understand? But you can also tell that lithium will have higher density as compared to sodium and lithium. Potassium will have higher density as compared to sodium and lithium. Why? Because as you move down the group, the density increases. So sodium will have more density than lithium. Potassium will have more density than sodium. Rubidium will have a higher density than potassium, but a low melting point, because if you go down the group, the boiling point decreases. Do you understand this?
Yes.
A simple idea, you can get a simple idea by looking at this chart. Melting point, boiling point, and density. Lithium has 180, almost 180, 1330. Sodium has 98. Potassium has 64. Rubidium has 38 degrees Celsius. You see, the melting and the boiling point are decreasing if you go down the group, right? These are group 1 elements. If
Yes.
you're going down the group, they're decreasing.
Yes, they are.
688. But if you look at the density, it increases 0.53, 0.97, 0.86, 1.53, and all of that. So the density is increasing. So you should be able to predict easily by looking at them. For any
Yes.
metallic group, if you go down the group, their reactivity will be increasing, their melting and boiling points are going to be decreasing, and their densities are going to be increasing. You understand this?
Yes, sir.
All right. Now this is the chemical. Let's discuss chemical properties of group 1 elements. Chemical properties of group 1 elements. Alkalis are very the alkali metals are reactive metals. They are reactive. All right. They are stored in oil to prevent them from reacting with water in air. All right. They react violently. They react violently with the water. And as you go down, this violent reaction increases and increases. All right. They have only one electron in valence shell, or in other words, they only have one valence electron. They readily lose this electron. to form cation of 1 plus, right? All right. They have similar chemical properties. All right. Is this clear? You guys are supposed to be writing, right? Which
Yes,
part?
sir. I am writing
You're writing.
everything. I will.
Very good. Very good. Go ahead. One thing I forgot to mention over here, they have low densities. They have low densities and they float on water. Not all of them. Not all of them, but potassium and lithium. Like lithium has the lowest density. It floats. It floats on water, and similarly, if you mm, sodium also kind of darts around, darts slash floats. For potassium, it melts immediately. Only these three. As you go down, their uh, density increases and they tend to sink. So the first three, you can say the first three, they float on water. Okay.
Yes, sir.
All right. The chemical properties. So we have two reactions for them. Their reaction with water and their reaction with air and their reaction with halogens. All right. So their reactions. So number one, with air, or you can say with oxygen. They readily catch fire. We're talking about all alkali metals, all right? Catch fire if exposed to air, forming a white solid, right? Like Na plus O2 is going to give you this white solid, all right? The reaction becomes more violent as you go down the group. The next important reaction is with water. So all alkali metals, they react with water. All alkali metals, all alkali metals they react with cold water. Cold water means the water that is at room temperature. Cold water means the water that is at to room temperature. We'll see that warm water and steam. Cold water, warm water, then steam. All right. We'll see the lesser reactive metals which we are going to see in group 2, and further the transition elements. They generally, they in group 2, they do not really react with cold water, so they react with warm water or steam, but they react with cold water, which means the cold water means that water that is at room temperature. All right.
Yes.
And form hydrogen gas and alkali. Obviously that is going to be an aqueous solution, right? Let's take an example. If you have lithium plus water, you get lithium hydroxide plus hydrogen gas, aqueous. This hydrogen gas, bubbles, effervescence, liquid to 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 this is a very lithium floats on water. Secondly, reacts violently, sorry, reacts quickly, and no flame. These are the things that you would have to memorize. No flame seen. All right. Then we have potassium, sorry, sodium. Sodium reacts quickly. Sodium plus H2O, sodium, lithium, sodium plus 2 to sodium liquid is going to give you sodium hydroxide. Sodium hydroxide is aqueous, obviously, plus hydrogen gas, as we have already studied. So reacts quickly, reacts very quickly, very quickly. You see, lithium only reacted quickly, but sodium reacts very quickly. It melts and floats on water, and yellow flame is seen. Yellow flame is seen. You see, these flames are going to become darker and darker, showing the intensity of the reaction. All right. And the last one is potassium. Potassium reacts with water, 2H2O, to give you potassium hydroxide, aqueous plus hydrogen gas. All right. This is even more violent, reacts violently, reacts violently, and you see, it floats and melts immediately in the solution, in the water, because it has reacted very violently, very quickly. And lilac, purple flame, is seen. You see the intensity of the flame as you go down. Rubidium, caesium, and francium, they are going to even react more violently. All right, very violently, extremely violently, as you go down. You understand?
Yes.
Right. So what are the observations generally you see when they react with water? With water, when they react with water, what are the observations? We see number 1, floats on water until melts, right? It ignite and make a fireball with the color. Then explosive reaction. This is an explosive reaction. That is why it is not recommended to be performed in school laboratories. You're going to get a question for that, right? It can be an explosive reaction. You understand? Then the last one, the last reaction that we have to study is with halogens, or you can say with non-metals. With halogens or non-metals, they form ionic compounds, or you can say salts. All right, like sodium fluoride, lithium chloride, potassium chloride, or potassium sulfate, and all of that. Okay, is this clear? Any queries?
Yes, no queries.
So what we have seen up till now, going down the group, the reactivity is increasing, the atomic size is increasing, the density is increasing, their metallic property is increasing. So what is going on? Well, if you go group 1 element, you look at group 1 element, what is going on? Down the group, what increases? Increase in density, increase in atomic size, all right, increase in metallic property. What is that? What is metallic property, Elishba? Ability to give electron, ability to lose electron, increase in reactivity, right? What are the things that are increasing? Decrease in melting point and boiling point. Is this clear?
Yes.
All right, let's keep it till here, inshallah, today. And tomorrow we are going to be discussing the halogens, inshallah. Group 7 elements. Then we have noble gases, and then we have transition elements, and we'll be done with the periodic table. We'll move on to inshallah the metals then.